All right, guys, last video of the day. Put some context to some of the stuff that we've been talking about. And if you've taken physics before, you've probably heard a lot of the vocab. If you haven't, no big deal. You'll still be able to understand it. What I want to talk about is rate of change. I mean, that's what slope measures. When we're talking about finding the slope of a curve, we're talking about how it's changing at any given point. Well, in the physical world, when we talk about rates of change, we're really talking about velocity. And if you think about it, the average velocity, the average rate at which something is moving, is simply found by finding how far it's traveled over any given amount of time. We use the word displacement for that, how far it's traveled, and then time is time. Well, in terms of how that relates to what we're talking about, P and Q still, 2 points making that movement, and then finding how long it took to move that far. So if you want to, consider displacement as f of a plus h minus f of a. And then time. Well, how is time measured? Seconds, some type of unit of time. So let's just call it h over time. And that's the same exact equation or rational expression that we use to represent the slope at any given point on our curve. Now, the thing that physics people are always concerned with is not average velocity, but instantaneous velocity. What's happening at any one particular moment? Well, to do that, the displacement gets smaller and smaller and smaller and smaller. Again, Q starts to approach P. As well, the denominator gets smaller and smaller and smaller and smaller also. The incremental time shrinks. So when we look at our limit definition as h goes to 0, of f of a plus h minus f of a over h. As we shrink the time increment to something so small, we are starting to talk about instantaneous velocity. Okay, because as the time increment becomes infinitely small, you're talking about what's happening at any particular instant. That is instantaneous velocity. So when questions ask you to find the instantaneous velocity given a function, you're doing the exact same thing as finding the slope of the tangent line at a given point. Notation-wise, you're going to see things like S of t in problems. S of t in mathematics and oftentimes in physics is the position function. And as we said, really if you think about this as displacement over time, if you know the position of an object at any given point, you should be able to find its displacement. V of t is used for velocity. So if you're given a V of t equation or asked to find V of t, you are asked to find the velocity at any given time. Again, what you need to know is you do that via that limit definition as h goes to 0. Let the time get infinitely small, find the displacement, and divide the two by each other. So, for instance, just taking something that we've already done before, if our position function for a particle is represented by the equation 2x squared plus 4, and we want to find the velocity of that particle at t equals 2, all we have to do is go ahead and look at the limit definition for the slope of the tangent line and to find v of t. So v of t is the same as m, and we know that v of t is going to be f of a plus h. So when t is 2, I guess we need to find f of 2. F of 2 is going to be 4, 8, 12. So we'll have f of a plus h, so f of 2 plus h, minus f of a, which is 12, all over h. And we're right back to doing the problems that we were just doing in the previous examples. That's going to equal, we'll put a 2 plus h in for x squared. And simplify this, and we'll be able to find the velocity. distribute the two this time so as to not confuse anyone. I know that might have been a little confusing the last time. And again, if I ever get going too fast in the video, just pause it and look at what I've written and see if it makes sense to you. I'm going to combine my like terms. I have an 8, a 4, which is 12, and negative 12. Shockingly, the constants cancel out. I needed that because I need my h to factor out. So I have an h times 8 plus 2h over h left. And I'm going to take the limit as h goes to 0. That's going to leave me with just 8. So for a particle following the position function of 2x squared plus 4, its velocity at t equals 2 is equal to 8 units per time unit. So 8 meters per second, 8 feet per hour, whatever it may be in terms of units. We treat it the exact same way, just recognizing that in fact the velocity equation is the tangent line slope equation. So hopefully that gives you a good starting point. You feel a little bit more comfortable with the problems that you're being asked to work on. Again, be careful about the algebra, be careful about distributing signs, squaring properly, factoring properly. If you pay attention to those things, stuff should magically cancel out and leave you with nice easy limits to find. All right, best of luck. My apologies again. Have a great Rosh Hashanah, and I'll catch you guys next week.